No, the average rate of change isn't the derivative.
No, the instantaneous.
What's that? Yes, the instantaneous rate of change is. So this guy right here is related to this graph right here. See the secant line? This line where it crosses the curve in 2 points. You find the slope of that line. You find the average rate of change between these two x values. That's what the average rate of change is. It's just a slope. That's it. It's just a slope. And then we have the instantaneous rate of change. That's when you're just crossing 1 point right here. All right. The instantaneous rate of change, now we have a better definition of it, is as the change in x approaches 0. So meaning like there's no horizontal change. That was a funny noise that your phone made. Okay, and then so anyways, that's the limit right here. It's just the limit of the quotient rule, pretty much. Well, the quotient rule has the h on the bottom of it. The quotient rule is just this simplified a little bit more. It's manipulated a little bit, which makes it easier to work with. But anyways, that's instantaneous rate of change and average rate of change, right? Remember this stuff? Okay. Now let's look at this first problem. Okay, so for this one right here, the problem says Table 1 contains data on temperature T on the surface of Mars at Martian time T. So this is Martian time right here. Okay, collected by the NASA Pathfinder space probe. Okay, calculate the average rate of change of temperature of T from this time to this time. So what do you have to do? Well, let's just let's highlight those 2 times so that we can have them popping out for us. That's those 2 right there. And what was the other one? It was 905. 905. Now I hate working with time on problems because, especially if they're in hours and minutes, that's really hard to work with. It's really hard to not make a mistake. And so the smart thing to do would be to get rid of the hours part. Just make them minutes, and then you can just do regular subtraction with those. So we want to find the average rate of change. That's the change in x. No, I'm sorry. The change in y divided by the change in x. And so we have to find the difference between our y values, which is negative 7.1 or 71.6 minus negative 44.3. We're just finding the slope here. Okay, and then we subtract the x's on the bottom, so it's going to be 611 minus 905. But I don't want the hours and minutes thing, so let's get rid of the minutes. I'm sorry, the hours. So 6 times 60 would be 360 plus the 11. That would be 371. Okay, then we're going to subtract 9 times 6 would be 54 with the 0, so 540 plus 5, which would be, okay, so now, 27.3? Thank you, calculator man. And then on the bottom, yeah, on the bottom, what do I get? It's negative,
200 something.
come on.
That's 160 something.
65.
164.
No.
I was just saying.
Can you guys plug in your calculator really fast?
Okay.
Holy crap, I can do this by hand without...
174, right? Yeah, 174. Really?
174. Maybe 174.
You guys.
I can't believe I'm doing this.
Maybe 174. Maybe 174.
It's been a long Monday.
I know, right? Okay, then you divide that out. Need your calculator. So can you guys do that really fast? I think it's 0.157. I can't remember. So this is your average rate of change between those 2 points. Okay, the next one says use figure 3 to estimate the rate of change. Now, whenever it says just rate of change, it's talking about the instantaneous rate of change. Sometimes it doesn't say instantaneous; it just says rate of change. That's talking about the derivative. Okay, in this case, it gives us the graph, so we can find, we're not given a function for this red line, we're just given the graph. It says at 1228. So they give us the point at 1228. You would have to draw the tangent line right here. I would use like a straight edge of some sort, because then you could find another point on that line. Then you just find the slope of those 2 points, and then you would get the rate of change, the instantaneous rate of change at 1228.